Okay, today we're going to do section 6.2 in our book, which is about ellipses. So we're going to talk about what an ellipse is. We're going to graph and translate them, talk about the center, the vertices, the semi-major and semi-minor axes, the foci, and then we're going to briefly touch on eccentricity of an ellipse. And yes, in class, we're going to talk about domain and ranges, and we're going to find equations of ellipses. Okay, so definition, the locus of points, which just means the collection of points in the plane, such the sum of the distances from two fixed points, and those two fixed points are called foci, is a constant. Okay, so here's a center, your HK. You have two foci, F1 and F2, and those distances, no matter what point you choose, if you add those distances together, they are a constant number. Okay, so the segment containing the foci, F1 and F2, okay, the line that they go across is called the major axis. Okay, so if you have a horizontal ellipse, the major axis is horizontal. Okay, so your foci are on that horizontal segment, so it's a horizontal ellipse, okay? So if your ellipse is a vertical ellipse, that means that you have a vertical major axis and the foci are vertical, okay? The other axis, the minor axis, is the segment perpendicular to the major axis through the center. Okay, so there are 4 points where a major and a minor axis intersect, and those 4 points is the vertex, so that's the center, okay? There's a value that is from the distance that from the center to a vertex on the major axis, and that's the semi-major axis, while there is another distance represented with B that is from the center to a vertex, and that's on the minor axis, so we call that the semi-minor axis. So let me show you the picture so it will make more sense, okay? So again, HK, that's your center, okay? F1 is your focus, and then F2 is a focus, okay? So A, okay, is called the semi-major. B is your semi-minor. You have your major axis, okay, so that has the 2 foci on it. And you have your minor axis. You have your semi-major axis and your semi-minor axis. Okay, so your semi-minor, the B, your semi-major, your C, and the distance between the foci and the point for your semi-minor, those form a triangle. So because they form a triangle, they form a relationship. The relationship between A, B, and C is given by the equation A squared minus B squared equals C squared. All right, so let's talk about how to graph an ellipse. Okay, this is what you need. You're going to need to know your center, your HK. We need to know the A and B values. And the reason why is that the general of the equation of the ellipse, the working form, is x minus h squared all over a squared plus y minus k squared all over b squared equals 1. This is if the major axis is horizontal. If the major axis is vertical, the only thing that changes is the b and the a. Okay, so you have b squared as your denominator first. Okay, so and you're like, well, what's the difference between a and b? Well, the larger number is going to be a squared. Okay, so if your larger number is in the second denominator, your ellipse is vertical. If the larger number is in the first denominator, then that means your ellipse is horizontal. All right, so let's talk about how to graph it. So first we're going to graph the center, and the center is at 2, -1. So our center is at 2, -1, okay? Notice that the larger number is in the second denominator, which means that this is going to be a vertical ellipse, Okay, so 4 squared represents b squared. So that means since b squared is equal to 4, b is equal to 2. So horizontally, I'm going to go 2 out each way. The 9 represents the a squared. And so since a squared is equal to 9, that means that a is equal to 3. So vertically, I'm going to go up 3 from the center and down 3 from the center. So up 3, across 2. There's my ellipse. All right, so let's graph this. Notice how this is not equal to 1. So to get it equal to 1, you're going to divide everything by 144. So divide everything by 144, and then it just so happens that things cancel out nicely. 9 goes into 144 16 times, and 16 goes into 144 9 times, leaving you this nice, pretty work form. Okay, so now we have a center of 1, negative 1. 16 is larger, and it's in the first denominator, which means this is a horizontal ellipse with an a value of 4 and a b value of 3. Okay, so first we graph the center, 1, negative 1. And then we know that horizontally we're going to go 4, and vertically we're going to go 3. Okay, so there's our ellipse. All right, so now we're going to go backwards. We have to write an equation, okay, and they're telling us that it's a horizontal ellipse, which means that our bigger number is going to go in the first denominator. The center is at negative 3 and 2. The semi-minor axis is 4, and the semi-major axis is 5. So semi-minor, remember, is our b value, and semi-major is our a value. Okay, so this is the general work form. So our center, the negative 3, 2, is going to go in for our h and our k. The semi-minor is going to go in for our b, and the semi-major will go in for a. Okay, so when we plug those numbers in, we plug in negative 3 for h, we plug in 2 for k. That simplifies to x plus 3 and y minus 2. Now we plug in 5 for a, and we plug in 4 for b. And so 5 squared is 25, and 4 squared is 16. So that gives us our nice work form here. All right, so I'm going to talk briefly about eccentric. I'm not sure how much we're going to deal with eccentricity in the future, but I just want you to kind of get a definition for it. It's deviating from the established or usual pattern or style. Okay, so we have these pretty ellipses. We know what they look like, and sometimes they go weird, right? So they're not going to be a circular path. They're going to be a different path, okay? So your eccentricity, okay, is calculated by getting the square root of your a squared minus your b squared all divided by a. So remember, your a is found from your major axis, semi-major axis, and your b is found from your semi-minor axis. Okay, so those are where those values are coming from. So you plug this into your formula, and then you can tell me how much is this ellipse deviating from a typical, normal, perfect circle. How much is the ellipse deviating from that circle? Okay, so your eccentricity, your E, is going to range from 0 to 1. So if you get a number less than 0 or greater than 1, then you calculated incorrectly. You need to go back and calculate again. All right, we're all done.